Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
And recently he's been interested in looking at topics of meetings and how to summarize them and how to browse them. So today he's going to be telling us a little bit about his work in that area. Professor Wimnicki.
Thank you for coming. What I'd like to do today is to talk some work we've done have been doing on essentially on summarization, although the name of the project is more grandly referred to as the briefing assistant, mostly because we see this branching out in different kinds of summarizations and reports. This is work that's currently taking place, or is currently funded by the DARPA PAL program. And the focus of this program is essentially learning. How can we build systems that sort of experience the world and gain knowledge thereby? More specifically, it is looking at a human assistant paradigm. So the idea is not to have systems that learn to replace humans or do something as good as or better than humans, but rather ones that observe what people do and figure out ways of helping them do it. Now, there are a couple of projects within PAL. Today I'm going to talk about a piece of one of them, which is called Radar, and that's situated at CMU. The general sort of idea there is to look at crisis management. Specifically, the scenario we're working on is that of you've organized a workshop or a conference, and then suddenly the building disappears or something else happens. What exactly do you need to do to reschedule the entire thing? In particular, how can an agent that learns from previous such occasions help you through this? So what I'll talk about today is one little piece of it called the briefing assistant. And this is a component that learns to create reports, essentially by observing how human beings create such reports, and tries to do it as good as or better, but actually simply just assist the human being in doing these things. So there's all sorts of a taxonomy of reports and summaries, but which I won't really go into. But let me tell you a little bit about what we're trying to do in this particular project. So we're interested in systems that actively acquire information about activity in a certain group or in a certain project, is able to take this information, which may be heterogeneous and of different kinds, and create digests and summaries of the stuff that's actually important. But it should also be able to understand that there are different ways of presenting information, and different kinds of information are relevant to different audiences. And in order to be able to do that, we really want an assistant that observes what a human author does when they produce such things. It can accept direct instruction, like do this, don't do that. And moreover, can look over a set of people doing more or less the same task and learn something more general about the process. So the summary assistant, very pragmatically, learns to create weekly summaries of group activity. And it does that, or hopes to do that, in two ways. One is observational, which is what I'll talk about today, and the other is instructional. Observational is essentially looking at what the human does and trying to model it in some fashion. Instructional is actually taking some kind of direct advice or rules, if you will, from the human. Another note here on how we would propose to evaluate these things. Essentially by looking at the quality of a draft summary that's produced by the system. The notion of a draft summary is here because we're really looking at something that's assistive. It's not producing the summary for you, but it's giving you a draft that you presumably can then fix up. And by extension, if the draft is really good, you're spending much less time on it than you need to. So the architecture is somewhat like this. So there's a set of information that comes from the participants in a project. This goes to an automatic summarizer, which generates a draft. And for our purposes, this is specifically a rank-ordered list of all the pieces of information that could go into the summary. And again, if the system is good and all the important items end up at the top, this goes to a human editor, which modifies it. And then the learning module essentially observes what the discrepancy is between the draft and the final summary, and tries to use that information to model the summarization behavior of the human. In order to work on these ideas, we did an experiment a little while ago in which we collected data of this kind from individuals in a project. Actually, it was our project. So we had a set of 7 people, each one of which was expected on a weekly basis to produce a set of bullet items that represented what they did that week. In order to kind of structure the process, we gave them a set of categories to work from, which is what you see on the right. So concrete achievements, what really happened, what were your issues, did you meet with people, and so forth. So this process gave us, in real time, and ran over about 16 weeks and yielded but exactly 334 items of information, essentially bullets produced by an individual on a weekly basis. So we did a bit of smoothing on that, essentially producing 12 more or less equal-sized units, which we decided to just call weeks. And the idea here is we wanted the tasks to be more or less the same across the weeks, rather than have very busy weeks and not so busy weeks. So in trying to understand what was going on, we looked at our data and tried to really understand what would go into creating a good summary. So we, among other things, ranked each item on this 4-level scale as to whether it was in fact informative or interesting, and used these to create reference summaries for the 12-week period. Now, given these summaries, we then tried to find a set of features that would allow us to learn which items are useful and which are not. And this is essentially done as a manual operation. We looked at the summaries, decided what kinds of things seemed important and how one might identify these, and did these features. Now, one thing we were careful about doing is making sure that these features actually related to specific word strings in the text. So although the features might be somewhat abstract, each one of them corresponded to a particular word or phrase in the input. And then we annotated the corpus, and this is actually what the annotator used to do this work. And then let's see. Well, this slide is a little more about the features that we have. So we decided there were maybe 31 features that were important, but about 10 of these turned out not to be. So we ended up with 21 features. And again, each one of these were tied to particular word strings and phrases in the text. And what you see there on the lower left is sort of an extract that shows that sort of markup. In terms of what sort of features we identified as interesting, we had the ones you see on the right. There are mentions of hardware, an idea, obtaining an object, things about organizations and people. We had one piece of metadata, which was who actually produced that item, who actually wrote that in the team, and also a set of processes, such as things being action items or expressing an aspiration or a commitment. This turned out to be rather interesting. There's an awful lot of aspiration I discovered in projects where people say, you know, I really ought to do X or we really ought to do Y. But typically that stuff sort of fades out after a while. But what's left are things like commitments. I will do this by a certain date and so forth. So to one degree or another, these kinds of types of information featured in the text that we were working with. So here's a little looking a little more closely at some of these. So I've mentioned aspirations, and here are a few more of these. So basically, we tried to have both a fairly useful, what we thought a fairly useful level of abstraction, but at the same time have these things concretely relatable to particular observations, if you will, in the text. So what we did in terms of the learning was very simple. We gave the summarizers an interface that presented them with the items for a particular week and asked them to check off the 5 items that they thought were important for that week, and then just to keep going through all dozen weeks. And as a result of which, for each one of these items, we had the corresponding features and can then model the expected rank of an item based on its feature content. So we looked at a variety of ways of trying to train this, and eventually we settled on logistic regression. One of the reasons being is this produces rather directly what we wanted, which is a rank ordering of the items. So it's a little more detail about the experiment itself. There were 7 people creating these summaries for 12 weeks, successive weeks, and the system was essentially trying to model what items they thought were important. Now, the data I'm going to report uses a metric called ESL, which is expected search length. We chose this one because it relates rather directly to what we're ultimately trying to optimize, which is, or minimize, I should say, which is the amount of work the human being has to put into creating the summary. And so the thinking is, if your model allows all the important items to bubble up to the top of the list, then once the user starts to trust the system, they're going to need to go, they do not need to go to the end of the list, and progressively we'll be looking at fewer and fewer items. And since reading is time consuming, then presumably they will become more efficient at this. There are a number of different ways of doing these metrics, such as, for instance, number of items in the top 10 or top n, and using other information retrieval metrics. But I like this one because it relates to ultimately what we're trying to do. So the short of it is the approach works. It's possible to build these fairly simple linear discriminant models and thereby more or less accurately predict what the expected rank is of an item, where the rank is determined by membership in the summary. To explain the graph a little bit, the ordinate is normalized by list length because the lists actually did vary a little bit. So that's really percentage or proportion of, that's not quite right. It's proportionally how deep you need to go into the list to find all of the items that appear in the summary. So you can see there's, in this metric, by the end of the course, there's what I have noted here is a 48% decrease in the ESL from the first to the last week. So concretely, what it means is that you don't need to look at more than 40 or 50% of the items by the end of the learning, compared to having to look at least 85% of the items to find all the important items. So this is kind of nice. It's a very simple technique, and it shows the result we wanted. So this is essentially the same data, but aggregated over longer periods to get some of the jitter out. I'll actually be showing data on the bi-weekly basis from now on, which is kind of smooth, but still kind of detailed. Let's see. So let me make a couple of observations about this. One thing that we concluded is that what's important over time isn't an absolute. So you see a fairly good decrease in the first 3 bi-weeks, but then things stall out. As near as we can tell, this had to do with let's say the change in the focus of the project at about that time. So things that are important initially maybe don't seem as important as the project evolves to other dimensions, along different dimensions. And however, the models we built were ones that cumulatively used all the prior data to find the parameters. Practically, one might either detect breaks in the mix in the project, or perhaps enforce some kind of window that doesn't go all the way back to the beginning of the project in configuring the models. In terms of how this contributes to the user's performance in the task, we found that indeed people got faster over time. But actually, I at this point don't put too much faith in this graph, since with any kind of task like this, or for that matter any task, people just get better over time as they figure out the details of what to do. So there's still an experiment to do there, which compares non-learning system with a learning system in terms of the task time. But at least on the surface of it, things do get better over time. So given that, we started asking a number of different questions. The first one being, is there such a thing as a global summarization model? Or more specifically, is there, for a particular document or set of documents, can one define a single abstract good summary? And with these data, we can actually ask the question by comparing the models that different people produced in this task. And what was, at least to me, not completely surprising is that there's a lot of variation in how, in the details of models. So your idea of a summary is actually different from my idea of a summary, which is different from someone else's. There might be some general things that people agree on, but everyone has their own emphasis. So what's nice about a technique like this, it actually models a particular view of summarization, and I think sort of finesses the issue of what is the correct summary for a document, and in fact transforms that into a more precise question, which is, what is the ideal summary for this document as produced with somebody with this particular approach to it? So this is essentially the numbers from the previous table, but done up in a lot more detail. So what's really odd about this is sometimes someone else's model is better for you than your own model, possibly because you're, actually I don't know why, but that's sort of interesting. So we tried to quantify this a little better by looking at things like inter-rater reliability. In fact, found those were fairly low. So people do in fact seem to be producing different kinds of summaries. Moreover, people seem to, drilling down a little more, people seem to use different selection criteria. They literally seem to be paying attention to different features when they put together their summaries. Irrespective of that, they're certainly internally consistent. Otherwise, the system would not be showing learning over time. So another question we asked is, what if we, okay, maybe the models are specific to an individual, but if we just pooled the data across all the individuals, what would happen? Presumably, if there was some sort of inner core to the model of summarization, having more data would give you better performance and certainly faster convergence. Well, it turns out that's not really the case, although you can sort of read the data in both ways. So what the graph shows is the learning shown by a merged model, which means all the markups produced for a particular week are used jointly to feed into the model, and the actual mean of the individual models. So the individual models do better than the merged model. On the other hand, they seem to be doing more or less the same by the end of the period. So I would take this to say that it's probably not unreasonable to consider priming the system with some kind of generalized model, but as long as at the same time there's a way of really just treating that as a baseline and then being able to converge to to the individual's view more rapidly. So just to further reinforce the idea that what people are doing is different, here are coefficients from the model for particular features from two of the subjects. So although certain items are kind of there or seem to be equally if you look at something like object gain, obtaining an object seems to be considered useful by several people. On the other hand, the overall mix is really very different. And if we, in fact, look at the data from another way, the different feature weights of the... so what this represents is, okay, let's ignore the fact that people are different. Let's just take the absolute weights of the features in the models, average them together, actually take the median, and see overall, is there any commonality in the kinds of things that people pay attention to when they make a summary. So according to this, people consider action items, commitments, and things that constitute an evaluation of the work to be rather important, as well as things like ideas, products. Things that don't seem very important is if you gain information, like read an article, for instance, or you express an aspiration, like I really wish I was doing this or that. So I think these results are fairly fairly representative of what's probably might be considered to be a core model of summarization. But again, any one summary is really a function of what the individual thinks is important. Nevertheless, if one were to build a baseline system, then presumably the thing to do would be to take some of these, what I call consensus features, and build on top of those. So far, I've shown you that it's possible to model individual summarization behavior. However, what we worked with were sort of engineered features. So it's not so much that, well, we sat down and figured out what the features were. In real life, this may not be the case, particularly if you want to take a system like this and start porting it to different domains where the actual features will become different. So the next question we asked was, can we somehow automate this process? So we tried two things. One was to build a automatic named entity extractor that was based on the word features, or the word, well, let's call them word features that supported the abstract features that we earlier identified. And the other thing we tried was to use n-grams as features, which is essentially not using features at all, except collecting the, actually that's not quite the right way of putting it. So you can take the text and you can simply consider the n-grams, in our case 1 and 2 grams, as being the features. And with a bit of cleanup, that gives us about 750 features, none of which had to be derived manually. So the question is, if we do kind of lightweight feature identification, which boils down to picking out what we think are important words in any one item without trying to abstract it, or if we even forget doing that and simply look at n-grams, how well can we do? So this is some detail of the experiments that we did. Basically, we didn't have all that much data, so we took a jackknifing approach where we trained the feature extractors on 11 of the weeks and tested on the 12th, but then just rotated through the set. I think this technique is also known as cross-validation. So in any case, if we do that, we find the following. The hand-identified features, and at this point you might want to just simply think of them as the hand-identified n-grams, do rather well compared to simply treating the problem blindly and considering the collection of n-grams as the feature set. Now there's some more results on this that came around after I made the slide, and that's the following. Turns out n-grams might be a little overinflated. With suitable tuning, the best performance is obtained by simply using unigrams. So just the words are enough without any real structural information. The performance there is still not as good as with the hand-picked features. So I think the best number we got with the unigrams was 31% improvement, whereas the hand-picked features gives us 38% improvement. But actually, that's not bad. So in some sense, you don't really need to know all that much about the details of what people are doing. Just knowing what their selection preferences are for the larger items. Okay, so I have some remarks here on where we want to take this work, but before we do that, what I'd like to do is to show you a short clip of a interface that we're using, or actually it really is meant to communicate the process that we're using for a replication of this work. So we did this with a project, and it was sort of essentially people like you and me who work on research. And we're curious whether the same idea worked in different contexts. So we arranged with a project course at CMU. It's an engineering project course that happened to have a weekly reporting requirement to allow us to piggyback our work on their work. So what happens in that case is the project is broken up into 6 groups of about half a dozen students each. They have a leader. Every individual is supposed to produce a report, bulletized report every week. And they've been doing this for years in this class. And we've added a further task, which is for the group leader to generate a couple of different kinds of summaries on a weekly basis. The summaries are of 2 kinds. There's the extractive summary that I've been talking about so far, which is you have, 20 items, and you pick out 4 or 5 of them that are important, but also an abstractive summary. Abstractive in this case means, in your own words, write a few sentences about what happened this week, as opposed to pick someone else's text. Abstractive summarization is actually a really interesting problem, and it's one that, at least to me, feels like the next frontier in summarization, since in some sense it's easy to pick out fragments of text, but it's more difficult to synthesize the knowledge or the information in the document into a fluent form. So let me first show you this, and then I'll talk a little more about it. There's no sound, by the way, so I'll try and... So if you just read, and then maybe I'll make comments as we go along. So as I said, there are... well, let's just keep this going for a bit. So the interface are taken from scratch as the students log into, or the group leaders log into the interface. They're presented with two kinds of items. There's time logs, what did you do and for how long, and kind of more detailed comments. Now notice what this person is doing. We've decided to have the item selection work, in terms of highlighting the words in an item that you feel are important. And this necessarily selects that item as being part of the summary, but at the same time gives us information about essentially feature information, or what we believe will be feature information. And there's a second section to the report, which is these descriptive items, and the same process is applied to that. So again, we get a set of summary items, and we also get information we expect to be sort of feature-like. So there's all sorts of stuff you do, and finally we ask the user to do their own summary, but for better or for worse, we actually allow them to check on their selected items and work from that. And just to make things a little more flexible, we allow them to go back and modify what they've done. And then finally, with all that, the user produces their free-form summary, and and that's basically it. And they do that once a week, Tuesday evenings, in time for their big meeting on Fridays. One thing I should also point out with this is that we have the application instrumented to a fairly low level, essentially the keystroke level. And what we're hoping to not only use this as a validation of the summarization process, but also as a source of data for how people go about the process of summarization within this context. I'm not sure what's going to come out of that, but we will have a fairly detailed time trace of how they go about selecting information and rearranging things. So again, the things, so part of it is a replication of the initial work, which is extracting items that are important. And the second one is meant to, the abstractive summary, the free-form summary, is meant to collect data for work or subsequent work on trying to devise techniques for abstractive summarization. So there you can sort of see the goal as being, here's a set of raw data, which happens to be these fragments of information. Here's a final summary. How exactly we transform that set into the summary. So the short answer is we're not quite sure yet, but some of the things we're interested in are what happens to information. So you can imagine that some pieces of information just, some of the information in an item goes directly into the summary. In other cases, there may be multiple input items that create a single summary. There may be items that appear out of nowhere and appear in the summary, so maybe some kind of evaluative comment might be of that kind. And of course, there's hopefully lots of items that just disappear and never appear in the summary. So formally what we're trying to do is, what we're hoping to do is to find a way of modeling that, that set of transformations, so we can go from a collection of raw facts or raw information into some kind of fluent summary. There are a lot of additional issues there, which is, for instance, fluency. How exactly do you make a bunch of disparate facts? How do you weave together a set of disparate facts into good prose? Where do these sort of integrative and evaluative comments come from, and so forth? So I wish I could tell you the answer, but we don't know yet. On the other hand, we feel this sort of paradigm is actually pretty well set up to allow us to answer some of these questions. So this slide says more or less what we're doing next, and some of that already appeared in the little video that I showed you. So basically, we want people to pick their own features, and I think this is really important. So what a couple of knowledge engineers think are important in a particular domain may not necessarily be what the people in the domain think are important. And moreover, if you want to have a technology that transfers from domain to domain with minimal developer involvement, then you really need to integrate the feature selection or feature identification into the task that the user is performing. So, and that in fact is kind of in the broader sense of the learning technologies that we're developing is an important goal. We don't want situations where people have to instruct the system necessarily, particularly on a very low level of pointing out features. It has to be something that's integrated into the activity as it stands. So for instance, the method of selecting items by highlighting important words is an example of that. There's one input, but we get two kinds of information out of it. So that's more or less it. So I've showed you the video out of turn, and I think I've described the future work. So hopefully what we want at the end of this is a technology that you can insert into a wide variety of environments that allows people to instruct their system on how to create summaries, useful summaries and reports. And this doesn't have to be text necessarily. It can also be just whatever the event stream, the total event stream might be in a particular environment. So it could be emails, it could be reports, it could be the fact that somebody published a paper, that other people had a meeting, and so forth. So there's all this information that can hopefully be woven together to identify candidate items for some kind of report. Something else that I'm very interested in is extending this into active information acquisition. So what we currently have is it's a very passive one-way process where people on the front line generate information, and then successive layers of other people abstract away from that to produce a report. It may be the case that in some cases, where in particular when you have a fairly strong idea of what the report needs to contain, that you should be able to spawn off what I call an interview agent that goes and locates particular individuals and queries them directly for information. So, for example, if I commit to getting a program done by if I commit to making this program work, and I don't say by when, you can imagine having an agent that then comes back to me and asks me directly, so when is this due? And really, or more generally, sort of fills out the kinds of information that would be necessary to make a well-written report. Another thing that we're thinking about is how to do summaries that are kind of not these situation reports, what happened this week, but something that's a little more extended in time. So give me a quarterly report, or give me an annual report, which involves not only picking out important information at a particular point in time, but actually fitting that information into some kind of narrative that spans over time. it's our impression that actually, if you take something like a research project, the kinds of things that can happen are fairly limited in scope. So you think up of an idea, you do some experiments. If they work, you publish a paper. If they don't work, you generate another idea and keep going. And in some sense, these are kind of standard plot lines in this kind of environment. And other environments would have their own sort of standardized or stylized plot lines. So what we're thinking is that if you have a stream of observation that runs, let's say, over 12 weeks or a year, if you have a system that's actually aware of the possibility that there are these stories or narratives running through it, then you have a structure by which you can digest and interpret the event stream, pull out those events that are particularly important in the context of a given narrative, and include those in a structure that describes the activity in that time period. Of course, this doesn't quite solve the problem of how do you go from that to a nicely written report, but I think it's a prerequisite of simply organizing the information that you need to then write about. And sort of way out there is the idea that you can have a system that can create a report with a particular point of view. So you might have a report that's from the project manager's perspective, and you might have another report that's from the perspective of somebody in the financial department, for example. And although the sort of the target events are the same, or the sort of the events you work from are the same, there's really very different kinds of reports that you can imagine being produced. And the final notion, which I frankly have no idea how anyone could approach, is to have systems that are able to produce reports and narrative that have the purpose of persuasion. So if I want to convince you I'm doing good work, or alternately that whatever we're doing really does fit into the mission, perhaps this is something that could be generated by such a system eventually. And that's it.
Time for questions. So if anybody's interested in talking to Professor Rudnicki, come and see me and see if we can accommodate. Thanks a lot again. Thanks, Alex.
Oh, thank you.